And so now we can examine how many users. Each user we saw from that woman, she had the number 1, has a different number. So the levels command will return that. And there are too many. Both R and RStudio will only give you 10,000. But so we can't really see. There are actually we could do length, I believe. Let's try that. There are 15,000 of them, but yeah, sure enough, there are 15,000 different users. Well, how about the artists? Because it's less than 10,000, it'll just list them all out. So we have 1,004 artists. They're the ones who make the music. Okay, so that's the pre-processing of the data. It's still not in a form that can be processed directly by a priori, but we'll deal with that. Okay, so we load up the A-rules package, and with the library command, you could also use require. Require does the same thing, basically, but does not. Library actually attaches it. Require does not. Require, I believe, just makes it available. Okay, and so we're going to create a new file that we call playlist that we will be able to manipulate directly. And we're going to use the split function. And what split does is it will take our long form and it will create a list where each component of the list is a different user. So we're not making a data frame. We're going to make a list. But data frames actually are lists. So a list where each component is a person is the same, is equivalent, or can be used in some cases just as if a data frame where you had each row as a person. So that's what we're going to do here. And split, did we take a look at it? We didn't. Let's take a look at it. X is the first argument, is the thing that you're splitting up. And so all we're doing is we're just using that one column. And F is the factor. Okay, so what we're doing is what we'll end up with is we'll have each component will be a factor user, and then we'll have the artists within that, which is what we need. Okay, so we do that, but it's not a data frame. Okay, so I found this a little confusing at first, but okay, so we do that, and then let's take a look. And so you can process lists with a priori. Well, it's too long, but each component, you have the components, and then within the components you have the artists. Component is a user. Okay, so we just want to know for each artist the unique, we just want to know for each user the unique artist that they listen to. So we're going to use lapply, and with the unique function, lapply will process a list, and we'll go through each component, and it will just pull out the unique artists that are at each component level. So we do that, and now we can take a look at it, and it knows. Now it's just taking a while to. And again, we can't see anything, so let's just look at the first two listeners, the first two components. So how long is this thing, playlist? Well, it's 15,000. We have 15,000 components because we had 15,000 users. Think of it as it's more or less equivalent to a data frame where you have 15,000 rows. So let's just look at the first two. So here are the first two users, which have number 1 and 3. And these are the artists that the first one listened to. Remember, there were 16, so those 16. Even though there are 104 possible levels for these artists, we stripped out the duplicates, and so that's just a list of the unique artists that first customer, first user listened to, and then here's the second one. So the second one, who is number 3, that's just his identifier, his or her identifier, listened to 29 artists. Okay. To process it, actually to process it by the a priori function, the a priori function is the main function of the a rules package. You can process it directly using a priori. You can process a list or a data frame directly using a priori, and it will coerce. It will force the object that is created to be a transactions type data type. Or you can use the as command. What this means is take our object, which is a list right now, and change it, coerce it into a transaction data type, and then just replace playlist. So we do that. And the reason we did that was because we don't want to run a priori right away. We want to run some other a rules functions to do some visualizations of it. And all of the functions in a rules can only they have to process an a rules class object, which is a transaction data type. A priori itself can process data frames and lists directly, but the other functions cannot. Okay, so item frequency, this is a method in a rules, and it will draw us a, okay. This is showing us exactly what it says, the frequencies. This is plotting the frequencies, but only for those that have a support. So there was nothing wrong at all. It was error. It was user error. Okay. Okay, now we're going to build the rules. And note here, we're building rules for support greater than this threshold. Oftentimes you want support to be lower than a threshold because you want the non-obvious pairs. But here we're trying to weed out the one-hit wonders. And we want rules that have a confidence of at least 50%, which means the rule is applicable at least 50% of the time. And this just generates the rules. We're running a priori, which is the main function, and I think it tells you somewhere. Here we go. 50. It generated 50 rules, which is a relatively small number. If you want to see the rules, you use inspect. So here's the inspect command. And we're going to filter them. But this is all 50 rules. And let's go up to the top. They are, here are the single item left-hand sides, 1 through 15. Then we have the double item left-hand sides, 1 through 16 through looks like all the way down. Okay, so we have single and double. And you get associated with each rule, you have a level of support, confidence, and lift. But we can filter this or present them and sort them by lift and confidence or support. So we're going to, we want the big lifts. So let's just look at the rules where we have a lift of 5 or more, which means essentially when the antecedent condition is met, there's a 5 times greater likelihood that the consequent will occur based on, as compared to records in which you just have the consequent. Okay, so, and we can do that. First of all, we're going to subset it such that we only get the rules. Let's look at the rules, first of all, where lift is at least 5. So we do that. And there are only 6 of them. But it would be even more useful to to examine this, to examine these rules sorted by lift from well, we're going to sort it by confidence, okay? So we're going to look at this. What this represents, these are the actionable antecedents. That is, or said a different way, if you want to propose to people who watch these, you want to make a suggestion about some other artist they might like to see, you have empirical data that these artists correspond to whatever people watch these antecedents. But these rules don't occur all the time. Even though the lift is high, sometimes the rules just fail, and that's what confidence tells you. Okay, so we're going to sort it by confidence. So we see the high confidence ones on top. So if you recommend it, this is a recommender system. You want to recommend additional artists based on what people have seen. You're going to be right 60% of the time here.